This is not an animal. It's an autonomous sensor array, the box jellyfish. It has no brain, yet it hunts with 100% precision in murky water. It relies on 24 eyes, some with lenses and corneas, just like yours. These aren't just for light. They are used for image formation and obstacle avoidance. It performs associative learning. It remembers collisions and remaps its path. This is a decentralized command center. Distributed intelligence at its most extreme. Now, consider the payload. The tentacles are covered in thousands of nematocysts. These are not stingers. They are high-pressure, mechanical, biological syringes. Upon contact, they inject a toxin cocktail that shuts down the heart in minutes. It is a surgical predator. It doesn't use force, it uses chemical shutdown. This creature is a masterpiece of decentralized biological engineering. Think about your own existence. You rely on a centralized brain for every decision. The box jellyfish proves intelligence doesn't require a command center. It is an anomaly. Evolution has perfectly optimized it for its niche. We call it biological horror. Science calls it peak adaptation. The line between a biological organism and a machine is thinner than we think.
Ambystoma mexicanum, the Mexican axolotl, a biological paradox suspended in perpetual metamorphic arrest. What you are observing is neoteny, the retention of larval characteristics into sexual maturity, an evolutionary anomaly. 6 external gill stalks, 4 limbs with distinct digits, a laterally compressed tail, all features of an aquatic larva. Yet this specimen possesses fully functional reproductive organs, a mature organism in juvenile form. The anatomical engineering presents a unique physiological blueprint, one that defies conventional amphibian development. But the true anomaly lies not in what this organism is, but in what it can do. Ambystoma mexicanum possesses the most sophisticated regenerative capacity documented in any vertebrate species on record. Complete limb regeneration, not scarring, not healing. Regeneration. Perfect reconstruction of bone, muscle, nerve, and vasculature. The process initiates within hours. Blastema formation occurs within days. Complete structural restoration, 60 to 90 days. The mechanism. Blastema formation. A mass of dedifferentiated cells that retain positional memory and developmental plasticity. The capacity extends beyond limbs, heart tissue, spinal cord, portions of the brain, even retinal neurons, all regenerable. Gene expression patterns activate dormant developmental pathways. Molecular signals cascade through tissue matrices. Pluripotent cells differentiate with architectural precision, reconstructing complex tissue hierarchies without error. Vascular networks self-assemble. Neural pathways reconnect. Functional integration is complete and permanent. The regenerated structure is anatomically and functionally identical to the original. No degradation, no compromise. This regenerative matrix represents the most advanced biological repair system in vertebrate evolution. Yet this biological marvel exists within a critically compromised ecosystem. Lake Xochimilco, Mexico City, the species' sole natural habitat. Urbanization, pollution, invasive species introduction, The habitat has been systematically degraded over decades. Wild population estimates, fewer than 1,000 individuals. A 95% decline in 2 decades. IUCN classification, critically endangered. Functional extinction in the wild is considered imminent without intervention. The species survives primarily in laboratory populations where its regenerative mechanisms are studied for biomedical applications. The regenerative pathways documented in Ambystoma mexicanum hold implications for human tissue engineering and regenerative medicine. A biological system capable of perfect self-repair, facing extinction. The paradox is complete. The analysis concluded. This is the Mantis Shrimp. It possesses the most sophisticated biological spring mechanism in the ocean, capable of delivering a strike with the force of a .22 caliber bullet. The strike is not muscle-powered. It is a dual-phase hydraulic system. Using a specialized saddle of elastic tissue, the shrimp stores immense potential energy. When released, it undergoes a phase shift, a power amplification stroke. This speed is so extreme it causes cavitation. The water itself boils and collapses, creating a shockwave of heat and pressure that pulverizes prey armor instantly. Absolute power requires absolute perception. The mantis shrimp's compound eyes are the most advanced in the animal kingdom, capable of processing polarized light and ultraviolet wavelengths. It does not guess the trajectory. It runs a real-time targeting algorithm, calculating refraction and distance before the cavitation bubble even forms. The strike takes less than 3 milliseconds. Nature's ultimate hammer is a masterpiece of kinetic engineering. Once the energy is spent, the environment is reclaimed. The prey is already gone.